Okay, so now we're going to test for the halides. 3 halides we're going to test for: chloride, bromide and iodide. So remember, it's not chlorine, bromine, iodine, it's chloride, bromide, iodide. They are the negative ions, the halides. So I've got a solution of each one. So obviously I know that they're there, but I'm going to show you what a positive test looks like. If you're doing these on unknowns, you wouldn't know that it was chloride. It could be not a halide at all, or it could be any one of these 3. But we know what's in these ones. So I know in here I've got potassium chloride, potassium bromide, potassium iodide. But I want to prove that it's those halides. So first thing I do is I add nitric acid to rule out any carbonate, because carbonates can react with silver nitrate as well. So any nitric acid will react to any carbonate which could be present in the water. You might see a little bit of bubbling, and the carbonate has been removed, and you're free to get on with your halide test. If it's a chloride, you get a white precipitate, a bromide, a cream precipitate, and iodide, a yellow precipitate. So let's do that bit first, and we'll see where we get with that. So first of all, add my nitric acid to all 3. A few drops to each. Okay, there's no bubbling there, there's no carbonate, or very little carbonate if there is. Give it a little bit of a swirl. Okay. Right, now to each one I'm going to add some silver nitrate solution, quite dilute, 0.05 moles per dm cubed. Okay, so I'm looking out for precipitates. So I'm just going to put this around it just to see if we can see it a little bit better. Any precipitate that might come along. Let's just put it on like this first. So let's put. So this is the first one. This is the chloride. Okay, definitely precipitate there. See it there, it's got the opaqueness. So I swirl it, it mixes a bit more. It's opaque, you can't see through. I would say that's white. I'll do the bromide. Okay, so let's precipitate there again. Now, see, it's quite hard to say, you know, is that white or cream? You compare the two. So see, the bromides are kind of, it's like a different shade. Not the easiest thing to see. You can only tell by comparing them, really. If you take it by itself, which that's white or cream. Oh, cool. Next to it, you can see this one is more of a white, and this one's a slightly off-white. Okay, and then the third one, iodide. Okay, let's precipitate there. And that's not come up that well on your. I can see it better here than you can on your screen there, but that is a yellow colour. Right, well, I guess the point I'm making is it is quite hard to tell the difference between these 3. Yeah, look at that, they almost look exactly the same, don't they? So, what do we do to distinguish them? Like I say, seeing it live, you can see it's slightly better. You do have a white, cream and yellow precipitate, but particularly and the yellow one is more yellow than it is on your screen there. But the difference between the white and cream is quite hard to distinguish. So we do these secondary tests. We add dilute ammonia. Only the chloride should dissolve in dilute ammonia. The other 2 stay there, the precipitate will stay there. So let's try that. So I've got here some ammonia solution, dilute ammonia. For that. So I'll take the chloride one here, and I'm going to add give it a shake. A bit more. You can see it's starting to dissolve. It's going. Okay, there's still some precipitate there, but it is dissolving. You see at the top there. See the label through there. Okay, still the same to the bromide. Oh, yeah, that's still up. Okay, the bromide, you still can't see through that. The bromide has not dissolved at all in dilute ammonia. Let's check the iodide. Insoluble. Okay, so the chloride has dissolved. Not a huge amount. I'll say it's not. I wouldn't say it's completely dissolved. I might have to add some more ammonia to that, but it's certainly dissolved more than the other two. Now let's try and see what happens with concentrated ammonia. Okay, concentrated ammonia, so it's much stronger than what I was using. So I add some of that into here. And we'll see if this makes any difference. So you can see already the bromide at the top, as I mix it, it's dissolving. Okay, you can see a solution here. Okay, the ammonia, concentrated ammonia, is dissolving that there. Let's see if I can get a button to invert that. The iodide, not making any difference there really. Okay, so with the chloride, you can see it's more dissolved now. I dissolved in dilute ammonia. Okay, you can just about see through that. Bromide did not dissolve in dilute ammonia, but it does start dissolving concentrated ammonia, and the iodide didn't dissolve in any. So the whole point of those ammonia tests is because those colours are quite hard to differentiate between, especially if you're only doing one. So what we do is we test it with the ammonia. Is it soluble in ammonia? If it's soluble in dilute ammonia, it's the chloride, so the precipitate is dissolving away. If it's not soluble in dilute but isn't concentrated, it's the bromide, and the iodide is not soluble in either. So it's like a secondary confirmation test. So what were the reactions that are going on there? Like I said, each one of those was the potassium halide. So we have the three reactions there. Potassium chloride reacting with silver nitrate to make silver chloride, that's the white precipitate, and potassium nitrate. Then you make silver bromide of this one, which is the cream precipitate, and silver iodide, which is the yellow precipitate. So if you look, the silver nitrate is always aqueous, so the nitrate's aqueous on this side, and always aqueous on this side, so that's the spectator ion. And the potassium is always aqueous on this side, and always aqueous on this side, so that's the other spectator ion. So if we take those away, we're left with just the ions that are actually forming the precipitates. So the first one, we've got the chloride ion, aqueous, plus the silver ion, aqueous, making AgCl, solid. Bromide, aqueous, silver, aqueous, AgBr, and so on. Okay, so these are the ionic equations which we've taken out from the overall equations.